Hey guys, it's Jillian, and today we're going to go over common factors. Hang on, let's just get focused here. So, we know what's common in something, and we know what's different. We know what the word common means. So, let's take a look and see what is common in each of these polynomials. So, here, remember, we broke this down earlier in a different lesson. We said 12 is 2 times 2 times 3, and then there's 1, 2, 3, 4 b's, plus 18 is 2 times 3 times 3, b, and then we look and see what's common, and we write it down here, and then we write down what's left. So let's just take a look this way. Here I've got a 2 in both of them and a 3 in both of them. So what's 2 times 3? That's 6. And then I've got 4 b's here and 2 b's here. So let's take out these 2 and these 2. So I've taken out 2 b's. And what's left in this first group is 2 and 2 b's. So that's 2b squared plus, and what's left here is 3. So basically this is the reverse of multiplying out your brackets, which basically means that if you distribute this in, you should get the original answer or question. So let's try it. 6 times 2 is 12. B squared times b squared is b to the 4. 6 times 3 is 18. B squared. There we go. So another way of looking at it is not going right down to the prime factors, but thinking of the number that is biggest that divides into both of these numbers. So we know 6 goes into 12 and into 18 evenly. And so that's another way of looking at it. Let's try B down here. So for B, let's see, what is common in 2, 12, 10, and 8? What's the biggest number that divides evenly into all of those? Well, that's 2. And then let's look at the variables. A, so they all have an A, but they don't all have an X. Nothing else is common. So when we take out a 2 and an A, well, 2, and again, you can look at it one of two ways. You can say 2A times what is that? Or you can say that divided by 2A is, and write it down. So 2A times x is 2ax plus 2 times 5 is 10. And a times y is ay minus 2 times 4 is 8. And a times z is az. So that's another way of looking at it. Let's try it again. What goes in here? 2, 6, 15. Nothing. Let's try the variables now. A squared A, nothing. This can't be common factored. No common factor. And you'll notice sometimes when you're given a question it says factor if possible, that's a clue that maybe there's going to be some questions that aren't possible. So let's take a look here. Now, what is common doesn't necessarily have to just be a number or a variable. It could be a binomial that's common. So for example, let's take a look here. In this group here and this group here, so terms are separated by plus or minus signs. What's common in these two? They both have a y minus z. So we would common factor out the y minus z, and then we would write down, we wrote it here, and then wrote a bracket and did the rest. So here we write it down, do a bracket, and then write the rest. What's left is 3x minus 2. Let's take a look here. What's common here? We have this and this. They both have an a plus b. So when we take out the a plus b, what's left? 7 minus 2x. Here, let's take a look and see what's common. Now here, we have to sort of go over a little something before we continue. You know how this simplifies to negative x plus 2. And you know how 1 plus 2 is the same as 2 plus 1? Order isn't important with adding. Okay, so then if that's the case, then we could rewrite this as 2 minus x, right? Positive 2 minus x. These are equal because order doesn't matter when you're adding two things. So if that's the case, what I want you to see here is that this with a negative in front simply means it's equal to the swap. 2 goes here, x goes here. So let me show you a few examples. If you have 5 minus x, that's the same as negative bracket x minus 5. You change the sign in front, there's a plus there, right? When you don't see anything, when you change the sign in front, you flip these, but the negative stays. So let's try another one. When you have negative x plus 7, oops, you need a negative in the bracket to make this work. When you have negative x minus 7, that's the same as change the sign and flip 7 minus x. So if that's the case, then check this out. Here, it may look like we don't have two of the same the way we did here because these look different, but wait a minute, when I examine them a little more carefully, I see, hey, these are the exact same, just flipped with a negative sign. And seeing as we know this here now, then that means that I could change this to the following. So I'm going to keep this 3m minus 5. And then what I'm going to do is I'm going to change this 5 minus 3m to 3m minus 5. But when I do so, the number in front has to change its sign. So if that's minus 3, now it becomes plus 3. And now I have a question where I can common factor out the binomial and then write down what's left. Let's try another one. Here we have 7 minus y, and here we have y minus 7. So I could just keep this and change that from positive 4 to negative 4 and flip. And when I do, these are the same. And now I can common factor them out and then write down what's left, 5x minus 4. Okay? Now let's take it even a step further. Here it says to factor a polynomial by grouping, which is kind of like this. This is the step. We're going to learn something and then we're going to apply this. To factor a polynomial by grouping, group pairs of terms with a common factor. So ax and by, nothing's common. But if I rearrange these two, then I've got ax plus xb minus by minus ya. Right? I just flip these around. Now I'm going to common factor what's common in these two groups. So first I'm going to take out an x because that's what's common there. And here I'm going to take out a negative y. They both have a negative y. Right, so when I take out a negative y, I'm left with positive b and positive a. Now wait a minute. Isn't a plus b the same as b plus a? Of course it is. We know 1 plus 2 is the same as 2 plus 1. So that means I can rewrite this like this. And then we have a question like this again, right, where we have factor by grouping. So here, what's common here is a plus b, and what's left over is x minus y. Okay, let's try another one. Here we go. There's nothing common here, so then let's change these up. So I flip-flop these two. They both have an a, the first two, and these both can be divided by 3. So let's give it a go and see what happens. So a, take it out, we have b plus 3. And then here, if I take out a 3, I have 3 plus b. I know b plus 3 and 3 plus b are the same, so I'll just write it out. These two can now be common factored out. And what's left is a plus 3. There we go. Okay, a little more on common factoring. We'll do two more grouping questions. So here, do these two have something in common to factor out? Yep, these two. Okay, so we don't need to rearrange this time. So here, what's common here and here is like 2 goes into both of these numbers evenly. And now let's look at the variables, and they both have an x. So 2x, and then I'm left with 2x plus 3y. Right? And when I multiply these in, I can check that I get those two numbers, or those two terms. Here, what am I going to take out? I can take out a 4 out of these two. So I'll take out a 4, which means that's 3y, and that's 4 into there is 2x. So of course these are the same because they're just in a different order. So let's write it up so it's easy to see that they're the same. And now I'm going to common factor those out. 2x plus 3y. And then what's left is this. Now, interesting, this bracket can be factored again, right? I can take a 2 out of here. So I'm going to take a 2, put it in front. And then when I take a 2 out, I'm left with x plus 2. Okay. Now you might think, should I put the 2 in there? No, like what we do, proper form is to put the simplest, like the 1 terms and then the 2 terms. So we do it like that. Okay, let's take a look at this one. And again, if this is going too quickly for you, then just replay it, pause it, you do what you need to do so that you have gone over it enough so it makes sense to you. So let's see here, those both have common terms or numbers, or factors, so let's see what we do here. So 4 goes into both of those, a goes into both of those, and b goes into both of those. So 4ab squared, so there's a b left, minus 4 goes into 12 3 times. I took out 1a, but there's another one there, and the b is gone. Now, here I can take out a minus 3 and a c. And when I take out minus 3, I'm left with positive b. When I take out a negative, that positive becomes a negative. And 9 divided by 3 is 3, and there's an a left over. So lovely. We don't have to take out a negative and do the flip-flop this time because they're in the same order. So we just continue. This is what's common, and we take it out. And this is what's left. And when we take a look and re-examine these, we see we don't have a situation like this where there's something to continue factoring. We're just plain old done, and that's it. Okay, let's take a look at, write an expression for the area of the shaded region in factored form. So we've done something like this previously. We know that when we have part not shaded and part shaded, the way to find the shaded part is to take the whole thing, find the area, and then find the area of the white part and subtract it out, and what will be left is the shaded. So the shaded area, so the area of shaded is equal to the area of the circle minus, let's do the circle, minus the area of the rectangle, right? Okay, let's go. So that is area of the circle. Well, area of a circle is pi r squared, and area of a rectangle is length times width. So let's see here, pi r squared. Do we know what the radius of the circle is? We do. It's 3x squared, and then the length of the rectangle is 3x, and width is 2y. So now that's 9x squared pi minus 6xy. Now actually, the right way properly to write this is to put 9 pi x squared minus 6xy, because 9 is a number, pi is actually a number. It looks like a variable because you don't see it as a number, but you know pi stands for 3.1415 blah blah blah. So we put the numbers first and then the variables. And then because it's area, we write units squared. Now let's take a look at this one. We want to find the area of the shaded region, so the area of shaded is equal to the area of the circle minus the area of that big square. So the area of a circle is 1/2, what am I doing? That's the area of a triangle. Area of a circle is pi r squared, and the area of a square is side squared, or length times width. So the radius, we see the radius is x plus 3, so we've got pi times x plus 3 all squared. And then the area, the length of the side, we have to figure this out. So we're going to have to do some work here and then plug it in because we don't have the side yet. Now, the side of the square is this. I'm calling it S for side of the square. And we know this and this are both, this is a radius, this is a radius. They're both radii. So this is x plus 3, this length. This is x plus 3, and that's an S. X plus 3, S, x plus 3. But you see that right angle? That right angle tells us this is a right-angled triangle. So I'm just going to draw this triangle right here outside of the circle. This is x plus 3, this side. This is S, and this is x plus 3. So we can find out what S equals using Pythagorean theorem. So let's see what it is. We know that base squared plus height squared equals hypotenuse squared, or a squared plus b squared equals c squared, right? So let's see here. This is, we just did this in the last lesson of special products, so we know we square the first, this times this doubled, so this times this is 3x doubled is 6x, square that is 9, plus, we know this is the exact same thing, so we'll just do it again, x squared plus 6x plus 9, and that equals s squared. That's 2x squareds, 12 x's, and 18 is s squared. Now, let's go back to here. This is s squared. We need to replace s squared here. So I'm just going to make this bigger. So s squared equals all of this. So I'm going to put all of this in for s squared. Now I'm not squaring it because this is s squared. This is s squared right here. So now I have to square this out. So that is, I'm just going to actually, I know we're supposed to line up our equal signs, but I'm just going to move them over a little bit to give us some room. So this is pi times, I'll square out this bracket. So first squared, this times this doubled, and that squared, minus this. Now, is there any way for us to collect any of this? Let's see here. So I've got here pi x squared plus 6 pi x plus 9 pi minus 2x squared minus 12x, right, because I'm distributing my negative in, minus 18. So let's see, my x squareds are pi minus 2 are the x squareds. The x's are 6 pi minus 12 are the x's. And then what's left with the constants is 9 pi minus 18. And then I've got units squared. So this is not your usual area question that you're used to, but it's applying what you know. and it's grade 10 math. So there you go for common factors and some area problems with